Now, lenses form images by refracting the incident light beam. So, we will now focus about the image formation by a lens for different positions of the object placed in front of it, and analyze about the nature of the image, that is, whether it is virtual or real. Position of the image, that is, it is in image form is in front or behind the lens. Now, image of an object formed by a spherical lens can be located by drawing ray diagrams. A large number of rays may originate from any one point of an object, but it is just sufficient to consider only two rays to maintain the clarity of diagram. Which rays to be considered? So, those rays are selected whose path after refraction from the lens can be easily determined. Such rays are commonly referred to as the principal rays or the construction rays. The point of intersection of the refracted rays gives the image of the point of the object. Image of an object formed by a spherical lens may be virtual or real. Real image is formed by the actual intersection of light rays. It can be obtained on a screen. Projectors form real images. When you happen to see a movie in a theater, it is through a projector, it is forming a real image. Even a camera is forming a real image. Virtual images form when the light rays may appear to be originating from a point but does not actually meet. It cannot be obtained on a screen. Rear view mirrors form virtual images. The image which you see in a plane mirror is also a virtual image. Now, these are the differences between real and virtual image. Real image can be obtained on a screen, virtual images cannot be. Real image is always inverted, whereas virtual image is always erect. Real images form when ray of light after reflection or refraction meet at some point, whereas virtual images form when a ray of light appears to meet at a point, rather I should say that appears to diverge from a point. It is formed due to actual intersection of light rays. It is formed due to imaginary intersection of light. Generally, three principal rays are used for construction of ray diagrams. Let's learn about these rays. We will start with convex lens. First, a ray of light parallel to principal axis of a convex lens always passes through the focus on the other side of the lens. So here you can observe that a light ray, this is the principal axis, and a light ray parallel to the principal axis is falling on the lens, and after refraction it is passing through the focus. So this is rule number 1, that a light parallel to principal axis after refraction passes through focus. Second, a ray of light passing through the principal focus will emerge parallel to principal axis after refraction. So over here, you can observe that this ray of light is passing through the focus, and after refraction, it becomes parallel to the principal axis. It is opposite to the rule number 1. In rule number 1, ray of light was parallel to the principal axis and it was passing through the focus. Rule number 2, a ray passing through the focus becomes parallel to the principal axis. Third, a ray of light passing through the optical center will emerge without any deviation. If you may recall, this was how the optical center was defined, that it is a point in the lens through which the light will pass undeviated. So here, this is a ray of light which is passing through the optical center and it is coming out undeviated.